So the first problem on here, we're going to do 20 and 58. First problem number 20, it asks to use sum or difference formulas to calculate the ratio of cosine 105. So 105 is not a unit circle rotation that we are used to, which are 30, 45, 60, 90, and so on. So what we have to do is take two unit circle rotations that we can use and make them add or subtract to be 105. So if I look at my 30, 45, 60, and so on, right off the bat, if I have a 45 and a 60, that adds to be 105. And now we can use a cosine sum formula. You may say, well, could we do, let's see, 135 minus 30? That would work also, because 135 minus 30 is 105, and 135 is a 45-degree rotation in the second quadrant. 30 degrees is also unit circle rotation, so that would work. And of course, for the first one, we use a sum formula. For the second one, we use a difference formula, and after we simplify all of that, it will give us the same ratio. All that being said, I'm just going to do the first one. You can attempt the second one if you want. Again, this is not your homework problem. Your homework problem is 19, I believe 15 and 19, so this will bode well for both of those. Cosine 45, cosine 60, again, I'm following the cosine sum formula, which is cos minus sine 45 sine 60. And now I'm just going to do my unit circle calculations. So I like writing out the parentheses here so we don't make that unfortunate mistake that understandably students make where they put like cosine of the ratio, like cosine root 2 over 2, sine root 3 over 2, and so on, where it's just the ratio. Cosine 45 is root 2 over 2. Again, not cosine root 2 over 2, just root 2 over 2. Cosine 60 is 1/2. Sine 45 is root 2 over 2. And then sine 60 is root 3 over 2. After we get our ratios, we now simplify by multiplying across. Root 2 times 1 is root 2. 2 times 2 is 4. And this is a minus, so I'm going to put a minus. You could also put a plus there, and negative in the numerator here. This has root 2 times root 3 is root 6, and then 2 times 2 is 4. Now we have like denominators, so we can put 4 in the denominator and then combine numerators, root 2 minus root 6. I decided to put the positive one first, and also those don't combine. Note, I did say earlier that I would do 58. I actually did 58 in class. As my students may know, if you're not my student, you didn't get 58, or maybe your teacher did do 58, but in any case, I'm going to do 62, which will cover how to do both of those. So I copied down all the info in shorthand. Cosine alpha is 1/2. Alpha is in quadrant 4. Sorry, it's a little sloppy. Sine beta equals -1/3. Beta is in quadrant 3. So first off, we need to draw a triangle for both of these. I suggest doing it on separate coordinate systems. So one, they don't accidentally draw one over the other, even though they're in separate quadrants. Two, it's just a little easier visually to look and find your ratios if they're separated as I have them. All that being said, cosine alpha 1/2 in quadrant 4. If you don't recognize that that's a unit circle rotation, which it is, that's okay. I would still suggest drawing the triangle adjacent over hypotenuse, so that'd be 1/2. So once you have the 1 and the 2, you could do Pythagorean theorem. So it would be 1 squared plus x squared, if we say that's the opposite side, equals 2 squared. Or you make it y squared, whatever. 1 plus x squared equals 4. Subtract, we get x squared equals 3. Square root x equals root 3. So this side would be a length of root 3. You have to move this in a little bit. Root 3. And it's going down, so it's negative. I suppose another way is if you saw that cosine alpha equals 1/2, you would go, oh, well, I know that means we're at a 60-degree rotation in the fourth quadrant. Cosine is x, so that's 1/2. And y would be negative root 3 over 2. And that's another way. And then you just use your unit circle rotations. That's another way you go about it. I'm going to go about it the triangle way. Not one's really more advantageous than the other, in my opinion. Okay, again, I'm going to have to move this over, give myself a little more room. Okay, now the next triangle, which is in the third quadrant, is sine negative 1 over 3. So opposite is negative 1. Hypotenuse is 3. And now I have to, that is not a unit circle rotation, and it's not a family. So again, I'm going to have to do 1 squared plus x squared equals 3 squared. You could speed this up and just say the side we're looking for is the difference of the squares, the square root of the difference of the squares, like this, which would be 9 minus 1, which is 8. So that'd be x equals root 8. And then that you can break down, simplify to be 2 root 2. So our adjacent side is going to be 2 root 2 here, and it's going to the left, so it's negative. Now we can get to doing our calculation. We have sine alpha plus beta, cosine alpha plus beta, and tangent alpha plus beta. First one, I'm going to look at the sine alpha plus beta, and then I'm also going to look at the tangent alpha plus beta. The cosine alpha plus beta will be very similar to the sine alpha plus beta. So first off, I'm going to write out the formula. I'm cool with you abbreviating to, and I highly suggest writing out the formula. It helps with plugging in the ratios. Sine alpha cosine beta plus cosine alpha sine beta. That's shorthand just to cut down on the writing. And then underneath, but I still, like I said, I think it's still important that you write this out. That's why I think that's a good middle ground by writing shorthand but still writing it out. So sine alpha, I got to go up to alpha and do opposite over hypotenuse. Opposite would be negative root 3 divided by 2 is negative root 3 over 2. And note if you did it unit circle calculation, the unit circle y value would have been negative root 3 over 2, so I'd give you the same. Cosine beta is, oops, sorry, I forgot to draw the beta in here, so now that's in there. Cosine beta would be adjacent over hypotenuse, which would be negative 2 root 2 divided by 3. Cosine alpha, we're going to come over to our alpha triangle and then do our cosine, which is 1 over 2, which of course is the same as what was given, so it'll be 1/2. And then I got to go sine beta. Sine beta is the exact same thing as given up here, but of course we could look at our triangle to be sure. Opposite over hypotenuse is negative 1 over root 3. Now that I have everything put in, I go ahead and just multiply straight across. Numerators, I have a negative times a negative, which would be a positive. I have a 2 out front. And then root 3 times root 2 is root 6. 2 times 3 is 6. I'm going to reduce that, not right now though. Plus, that actually a minus, because I have 1 times negative 1, which would be a minus 1. How about let's do it this way. Let's do a plus and then put the negative in the numerator. Divided by 6. And note, I actually am not going to reduce the 2 over 6 because that, as I didn't really have insight when I first thought about it. Now that I don't want to reduce it because I can combine these into one fraction because of like denominator of 6. Now, if I reduced it, I wouldn't have like denominators and I couldn't combine them into one. So now that I combine them into one, I have 2 root 6 minus 1. Next, let's look at the tangent alpha plus beta, tangent of alpha plus beta. So I do my tan alpha plus beta formula. So it'd be tan alpha plus tan beta. Again, I'm just doing the shorthand, T for tan alpha, T for the tan, and then alpha for alpha, obviously. And then 1 minus tan alpha tan beta. And now I'm going to plug in the ratios. So first I'm going to look for tan alpha. So I'm going to go to my alpha triangle and go opposite over adjacent. Negative root 3 over 1 is just negative root 3. Then I have a plus tangent beta. Beta is opposite over adjacent, which would be 1 over 2 root 2. Wow, that's going to look nasty. 1 over 2 root 2. So what's nice about the denominator relative to the numerator is we don't have to do any thinking. We simply plug in those two ratios. So I have a negative root 3 divided by, or that'd just be a negative root 3. I'm going to put it as negative root 3 over 1. It'll just line up these fractions a little nicer. And then I have a 1 over 2 root 2. So now the thought is, well, maybe I can multiply those together, the two fractions and the denominator, which I could. The other is multiplying by the LCD of the smaller fractions. So my fractions are negative root 3, smaller fractions, 1, 2, 3, 4, those smaller fractions inside the larger fraction. I want to find the LCD of all of those and multiply the top and bottom of the large fraction by that. And then what happens is that lines up with the numerators of the smaller fractions, and then our denominators cancel. So 1, 2, 3, 4. This denominator is 1. This denominator is 2 root 2. This denominator is 1. 1 is 1 over 1. And then this denominator is 1. This denominator is 2 root 2. So my LCD of all of them would be 2 root 2. So I'm going to multiply the top and bottom of the large fraction by 2 root 2. And when I do that, when you multiply the top and bottom of the large fraction by 2 root 2, this is really over 1. Make this division bar a little bigger. And then this, when distributed in, goes into the numerators. This as well, the bottom goes in the numerators. So we get some nice canceling happening. So first off, when I do 2 root 2 times negative root 3, I have a negative, on the outside I have a negative 1 times 2, so that'd be a negative 2. And then I have a root 3 times a root 2, which is a root 6. When I distribute this into here, the 2 root 2 over the 2 root 2 cancel, and we're left with 1. When I distribute in here, I have 1 times 2 root 2, which is 2 root 2. And then here, when I distribute this in into here, the 2 root 2's cancel, and I'm left with a negative root 3. And note we have a negative negative, so it turns into a positive. Now note this is a pretty nasty radical fraction we have here. Excuse me, but that won't be, I don't think you're going to have one on your homework that is this nasty, but nonetheless, we're still going through the process that you'll have to go through on the other problems. The ones you will have to do just won't be as difficult. Okay, so what we need to do now is multiply by the conjugate of the denominator to get the radical out of the bottom. So I'm going to multiply by 2 root 2 minus 3, 2 root 2 minus 3, top and bottom. And let's see what happens here. So let's go one at a time. Negative 2 root 6 times 2 root 2. Negative 2 times 2 is negative 4. Root 6 times root 2 is root 12. I'm going to just leave that for now. Next we have negative 2 root 6 times negative 3. Negative 2 times negative 3 is positive 6, and then we have a root 6 left over. In the bottom, it's just going to be multiplying the first and the last, so this times this and this times this. Why is that? Well, we're multiplying by conjugates. Conjugates, the middle terms cancel. So we don't even have to worry about multiplying them. So when I have my first case of 2 root 2 times 2 root 2, I have 2 times 2, which is 4. And then root 2 times root 2 is root 4, which equals 2. And again, I'm not simplifying yet. I'm just in the interest of instruction. If you can simplify right away, go ahead and do it. Then I have my last terms. 3 times negative 3 is negative 9. Okay, so at the top, negative 4 root 12. This right here would break down into 4 and 3. So we have root 4 times root 3. The root 4 goes to 2, which then comes out front and multiplies by that. So 2 times negative 4 is negative 8. And we will have the root 3 still underneath the radical. Again, I'll do the work over here. Root 12 is root 4 times root 3, which gives us 2 root 3. And then note, remember, we had a negative 4 out front that whole time. So then we have negative 4 times 2 is negative 8 with the root 3. Plus 6 root 3, or 6 root 6. No, there's nothing we do with root 6. And on the bottom, we have 8 minus 9, which is negative 1. And now I can just distribute that negative to the top. So I end up getting 8 root 3 minus 6 root 6. Don't think I made any mistakes, but we're all fallible, so we shall see.